Hello, I'm Mr. Muskeluk, your AP Chemistry teacher at ChemAdvantage.
This problem is about corundum, a compound made of aluminum and oxygen. In its natural form, it can produce beautiful sapphires and is quite expensive if you've got a crystal that has the right type of color and inclusions or a lack of them. However, corundum is pretty easily made now in labs using various processes, and you can just take this inexpensive aluminum and oxygen and make clear glass-like sheets. In fact, it's used often as watch dials because it's scratch resistant and very transparent. If you have a Apple titanium watch, it has a sapphire or corundum glass window that doesn't scratch readily. It's also used in windows of satellites because it's transparent in both infrared and ultraviolet, so you can get many frequencies of light to go through it without being stopped. But let's get back to our problem where we have aluminum oxygen, and let's say we want to find out what its formula is. Now here we're given some data. We've got a corundum sample weighing 418 grams, a lot of carats, but now, as I say, they're grown easily, and it contains 197 grams of oxygen. Okay, if we want to find an empirical formula, we want to find out how do the atoms combine in corundum, we should start putting the numbers into our formula. Here we've got our aluminum, and here we've got our oxygen. Well, oxygen, we know already. They're telling us we've got 197 grams of oxygen. Typically in an AP problem, they'll give you part of the answer directly, 197. This is a direct answer. But of course, we've got to figure out the aluminum, the other part of this formula, and we'll get our calculator out and do some subtracting because we've got a total of 418 grams, and we got to remove the oxygen from it, 197. That's part of your logical process. We've got our 221 grams of aluminum. Again, I would advise you to write this out on paper so you can see what the composition is. Of course, this is the mass composition. It looks like there's some more aluminum in this aluminum oxide than there is oxygen, but this is just weight, how much mass it has. The chemists are interested in numbers of actual atoms that compose this, so we're going to have to change both of these values into moles to be able to know what the formula is going to be, because the formula tells you in terms of atoms. So calculator again, and of course not just a calculator, but we'll need our periodic table. Here's our periodic table, and we know that we have, in our calculator here, 221 grams of aluminum. So let's change that into moles. And by now, please, I hope you remember, changing grams into moles is a matter of dividing by the molar mass, in this case 26.98 if you're into units, grams per mole. The grams cancel, the moles, which are the denominator of the denominator, say that 5 times quickly, will give us moles. And there is our answer, 8.19 moles of aluminum. Now we really know how much aluminum we have in this sample. This 8.19 moles. So we know the quantity. If you multiplied this by 6.0 times 10 to the 23, you'd actually know the number of atoms of aluminum. But we want this formula, so we're going to need to know the amount of oxygen we have. Well, I'm not going to need the periodic table for that because I'm sure you've memorized the atomic weight of oxygen. That's easy enough to remember. We'll take our 197. We had 197 grams of oxygen, and we'll divide that by 16.00. If you don't know the atomic mass of oxygen by heart, you really shouldn't be taking the AP exam. There, 12.3. We'll keep it to 3 significant digits, a little bit easier to see things, and we have 12.3 moles. Now we're really, really close to a formula. This really tells us how much aluminum we have and how much oxygen we have. Look, we've got 8. We've actually got less aluminum. Our formula is going to have less aluminum than oxygen because we're dealing with the numbers of atoms, and moles tell us about that. Well, this is going to be tough to figure out. Now, looking at this, I say it's got less, this. So really, what we should do is make this simpler by looking at the ratio. Divide the 8.19 by 8.19, the smaller value, that gives us 1. So we know we've got 12.31 moles of oxygen. I'll just divide that by my 8 1.19, and I'll put the extra fourth digit in just to get a little bit more accuracy, and no need for any more than that. 1.5. Yes, that makes sense. 8 to 12, and 1 to 1.5. So there is indeed more oxygen. Now, this really is a formula. It's valid as a formula, but we like to have whole numbers. It's a lot easier to see things, especially when you get other decimal equivalents like 1.33. So let's multiply to get a whole number for the aluminum. If we multiply this by 2 and this by 2, we still have the same ratio. We do get whole numbers. If this had been a 1 and 1.33, we'd multiply by 3. So if we multiply by 2, we get the formula of this compound. This really, really great material, this material that's got a Mohs hardness of 9, almost as hard as a diamond, and it's clear and infrared and ultraviolet. It can be made into beautiful colors. It can be grown into sheets. It's a really, really neat material. Aluminum and oxygen together, and this is the lowest whole number oxide.